logarithmic functions. Now, logarithms are very related to the exponentials we saw last class. Now, remember, an exponential function came in this form, where we had some base raised to a power equals some number. Well, a logarithm is simply the inverse. So a logarithm will look like this. It'll say I have a log here of some base with the number here written along with the log, like straight in a line. The base is down below it. And this will equal the power. So to adjust from one to the other, you simply rearrange. Let me give you an example. If our base was 2 and we raise it to the third power, that was 2 times 2 times 2. We know that would equal the number 8. So here our base is 2, our power is 3, our number is 8. Well, if I wanted to change it to a log, that would mean that log, with my base down low, which my base is 2, to the number, which is 8, will equal 3. And then you could type this in the calculator and check it. Log base 2 of 8 and press enter. And let's see what it gives you. If you go calculator, we would press the log button that's over here, control log base 2 of 8. When I hit enter, it should equal 3. And it does. So that's how these work. They go back and forth. A natural logarithm is when we have a base of e. That's what this means. Base of e. That's that number e that we learned about last class. All right, so let's get started. Here, this is just showing you what I showed on the previous slide of how we go back and forth, transferring from logarithms to exponential. So let's evaluate some of these. 2 to the 16th, if we want to know what that equals, you'd set equal to x. Now here's how you solve without a calculator, is you would just rearrange it. Now remember, this is the base, this is my power, and this here is my number. So to solve this, I'm going to say the base is 2 to the power of x equals 16. Notice what I did. I converted it to exponential to solve. Now I just need to know how many times does 2 go into 16. And the way I do this is what's called upside down division. I take the 16, and since I know I want it to be powers of 2, I divide it by 2. So I'm going to divide it by 2 here. If I divide it by 2, I end up with 8. If I divide it by 2 again, so I go here, divide it by 2 again, this time I get 4. And I'm going to keep dividing by 2 until all I'm left with is 2's. So I got 2 there, and it leaves me with 2. So notice there's 4 2's there. That means 16 is equal to 2 to the 4th power. So here we would say that x equals 4. And we'll try another one here. Let me just circle my answer. Now let's try this one. I'm going to first set it equal to x. And so I would say 5 to the power. That's my base. This is my number. This is my power. 5 to the power of x is equal to 1 over 125. Now, there's a couple of ways you can do this. Remember how we learned that a negative power will flip it? So you could say, there's a number of ways you could do this. You could say 1, as we could say 1/5. I changed the base to 1/5 to the power of negative x equals 1 over 125. Or the other way of solving this is I could say 5 to the power of x, 5 to the power of x equals, and switch this to 125 to the power of negative 1. Now that's the way I think it's going to be easier. So now I would say 125. If I wanted to solve, I would divide by 5 because that's what my base is. 5 goes into 125. 25 times, I would divide it again, and I would get 5 and 5 here. That means 5 to the 3rd equals that 125, but it has the power of negative 1. Okay, so this is basically what I saw so far. We know that 5 to the 3rd equals 125, but it has the negative 1 there, so I would have to say 5 to the negative 3rd equals 125 to the negative 1. That would be like raising them to the -1. So x would equal -3. That's what we established there. If you wanted to go this way, we would have this, and then you would ask yourself, you divide the same thing, 1/5 to what power gives you 125, and you go through the same process. The ones will be easy, but you would just say 25. 5 goes into that however many times, which is 3, but the power is already negative. So again, you would end up with the same thing. Let's try this one. Let's see if we can go through it a little bit quicker here. We know that this equals x. So I could say 3 to the power of x equals 1 over 27. But the way I'm going to solve this is I'm going to say that 3 to the negative x equals 27 like this. So I've just taken the power and I've flipped it. I'm just going to do it this way, because this is now saying, well, actually you would write it like that, but then you would end up taking the negative over. So I'd have 27 divided by 3 is 9. Divide 9 by 3 and you get 3. So we know that 3 to the third equals 27. That means 3 to the negative third would equal 1 over 27. So here we would say that x equals -3 again. Now let's try this one. Again, I'd set this equal to x. That's my base. 17 to the power of x equals 17. Well, that's easy because it's just 17. So it's got to be power of 1 here. So we just say x to the first is my answer. Now I got one for you to try.